Day 389 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2131, longest palindrome by concatenating two-letter words. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. You are given an array of strings words. Each element of words consists of two lowercase English letters. Create the longest possible palindrome by selecting some elements from words and concatenating them in any order. Each element can be selected at most once. Return the length of the longest palindrome that you can create. If it is impossible to create any palindrome, return 0. A palindrome is a string that reads the same forwards and backwards. Okay, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input words equals an array of strings LC, CL, and GG. The output is 6. Explanation says one longest palindrome is LC plus GG plus CL, which is a string LC, GG, CL, which has a length of 6. Note that CLGGLC is another longest palindrome that can be created. So let's break this down one step further. First, we need to understand what a palindrome is. So a palindrome is a string that reads the same forward as backwards. So as you can see here, LCGGCL reads the same backwards. If you read it backwards, it's still LCGGCL. So it reads the same forward and backwards. What we want to do is take a look at these input strings, and we want to see what's the longest palindrome that we can create from these strings. So as you can see, we take all of these strings, we take LC and we put that first, then we put GG in the middle right here, and then we put CL at the end. And that allows us to create a palindrome, and that's the longest palindrome that we can create with this input because we're using every string in this input, and that gives us a length of 6. So with that being said, let's go ahead and take a look at example 2, just where they give us a little bit more characters or a little bit more strings to work with. So in example 2, we have the input words equals an array of strings A, B, T, Y, Y, T, L, C, C, L, and A, B. This time the output is 8. Explanation says one longest palindrome is TY plus LC plus CL plus YT, which equals the string TY, LC, CL, YT, which has a length of 8. Says note that LCYTTYCL is another longest palindrome that can be created. So in this case, as you can see, we can't use the ABs because with the ABs, you see that they are the same, right? They're not reversed. AB and AB is in the same order. Whereas when you look at TY and YT, those are in reverse order. So we know we'll be able to use those when we make our palindrome. Same with LC. We have LC right here and we have CL right here. Since these are the same strings just in reverse order, we know that we can concatenate them as well to make a valid palindrome. So in this case, we use the TY and YT and LC and CL, and all together we get this string right here, TY, LC, CL, YT, or this string right here, LC, YT, TY, CL, and they each have a count of 8. Notice we're not returning the palindrome itself, right? We're not returning these strings. We're just returning the count of the strings. And in this case, it's 8. So let's look at example 3. One more example, so we might as well go through it. In example 3, we have the input words equals an array of strings CC, LL, XX. The output is 2. Explanation says one longest palindrome is CC, which is the length of 2. Note that LL is another longest palindrome that can be created, and so is XX. So in this case, we see that we won't be able to create any palindromes when we concatenate the strings, but it allows us to just use one of the strings as a palindrome in a case like this, right? So in a case where we cannot concatenate anything to create a palindrome, we can still use the strings as the palindrome themselves. As you can see, CC is the same forwards as backwards, LL is the same forwards as backwards, and XX is the same forwards as backwards, and they all have a count of 2, thus our output being 2. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution's not that difficult at all, so let's get started. Now, the first thing we're going to do is we're going to create a dictionary to count the occurrence of each word. So we're going to declare a variable. We call it word count, and then we'll say colon. It's going to be a dictionary, so we're going to open up the square bracket. It's going to be a string, colon, integer. Come outside of that, we're going to say equals a blank dictionary like this. Boom. Then we need a variable to store the total length of the resulting palindrome. So we need a place to store our output, right? Well, in this case, the output is 6, or in this case, the output is 8, and in this case, the output is 2. We need to store that somewhere. So we're going to create a variable for that. We're going to say bar length for the length of the palindrome. And then we're just going to set that equal to 0 to start, and that's where we're going to start our count from. Then we're going to create a flag to check if we can use a single word like AA in the middle, right? So similar to this example, we come across GG. We know we can put GG in the middle of CL or LC and CL. So similar to right here. So for that, we're going to create a flag for that. We're going to say for has middle, and we'll just set that equal to false. Boom. Now we need to count the frequency of each word in the input array. So we're going to say for word in words, we're going to open up the bracket. We're going to say word count, open up the square bracket. We're going to say word, comma, default 0, colon 0. Then we're going to say plus equals 1. So what this is going to do is every time we're going to work with our dictionary, our word count dictionary that we created up here. And every time we see a word, we're going to keep count of it over here, right? So we're going to start the value at 0. That's what the default 0 is. And every time we see it, we're going to increment that count by 1. That's what the plus equals 1 is. Then now we need to iterate over each unique word in the dictionary. So for that, we come outside this for loop, and we're going to start another for loop. And we're going to say for word in word count dot keys. We're going to open up the brackets. We're going to say let reversed word equal a string, open up the parentheses, word dot reversed, then put some parentheses at the end, and this is going to get the reverse of the word. Boom. Then we're going to come right here. We're going to say if word equals reverse word. So that means we found a reverse. So say we're looking at this word and we see if this word, we stored the reverse of this word already, right? So LC, we stored the reverse CL. So if we keep going through the array and we find another CL, that means the word this moving too fast. If the word is if word equals reverse word, first we're going to handle the case where the word is a palindrome itself, similar to this right here, GG or CC. So like if the word is reversed and it's still equal to the same word, that means we found one of these. We found a GG, or we found a CC or LL. We found a string that contains 2 of the same letters because they're all 2-letter strings. So for that case, we're going to open up the brackets and we're going to say let pairs equal word count, open up the square brackets, word. Then we're going to come outside of that and we are going to say divide that by 2. And this is going to use as many full pairs as possible. Then we're going to come right here and we're going to say length. Excuse me, y'all. Length plus equals pairs times 4. And each pair contributes to 4 characters in the palindrome. So then we're going to say if there's one word left or an odd count and no middle word yet, we can use it in the center. So we're going to say, we're going to come underneath that and we're going to say if word count, square bracket word, come outside of that exclamation point, mod 2 equals 1, and 2 and sign has middle, then we're going to open up the brackets and we're going to say has middle, has middle equals true. And then a single word in the middle adds 2 characters, so we're going to say length plus equals 2. Boom. Then we're going to come right here with this if statement and we're going to say our else. We're going to say else if word is less than reversed word and 2 and signs word count square bracket reverse word does not equal nil. So we're going to say exclamation point equals nil. So does not equal nil. Then with this case too, the word is not a palindrome and has a reverse counterpart in the dictionary. We're going to use the smaller count of the two to form pairs. So we're going to say let pairs, sorry, that says pairs, not pairs, pairs equal men, open up the parentheses, we're going to say word count square bracket word, come outside of that, comma, word count square bracket reverse word. Boom. And then we need to put an exclamation point here, and we need to put an exclamation point here. Then each pair contributes 4 characters, 2 from each word. So we're going to say length plus length plus equals pairs times 4. Boom. Now, after all that, all we have to do is return the total palindrome length that can be formed. So for that, we're going to come right here and we're going to say return length. And that should be all she wrote, y'all. Let's go ahead and give this a run. Make sure it runs properly before we submit it. Okay, we have an error, cannot find reverse word in scope. So this should have a D. Boom, let's run it again. See what happens this time. Must be unwrapped. So once again, we got to put an exclamation point right here and force unwrap it. Let's run it again. Oh, sorry, y'all. Cannot find pairs in scope. Oh, see, I keep writing pairs. This should be pairs. Let's run it again. Sorry about that, y'all. All these typos, I was moving too fast. Oh, now let's see. Cannot find reverse word. Should have a D again. That's why you cannot rush yourself, y'all. We can't rush ourselves. We have to do what we have to do. We have to make sure we get be particular and tedious as possible when it comes to this code and stuff. Everything has to line up and match up exactly right. Okay, so we got the wrong answer, right? So what that lets me know is somewhere along the line we probably messed up the math, and right here this should be exclamation point has middle. I knew something, yeah, because I marked that as true, and yeah. So let's see, let's run it again. Let's run it again, y'all. This is just an example of how things have to be right and you have to pay attention to what you're doing. And it's accepted, y'all, so let's go ahead and submit it. Make sure it's still accepted after we submit it, y'all. Let's see. Oh, 46 milliseconds beats 50% of users. Not bad. We'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to understand the solution that is presented to us. We've been doing some string problems. We were doing we did a few days of easy strings. I wanted to get a medium string in there so we could brush up and apply what we have learned so far. I figured this would be a good question for that and a good solution to that's easy to understand that we can all learn from. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.